Welcome. Today I am here to discuss a very interesting experiment done by Hertz in 1887 from the structure of atom, and the learning objective today is photoelectric effect. Dear students, Hertz scientist in 1887 he did a very interesting experiment. He tried some radiations on the surface of metal, and what he find out? Electricity. You find out electricity is coming out and electrons are ejected out. This ejection of electrons from the surface of metal, when the light of suitable frequency strike on it, is known as photoelectric effect. So dear students, this here metals are electropositive in nature. They have tendency to lose electrons, but the electrons are not totally free there, because electrons get attracted by the nucleus, right? Oppositely charged particles. So we need some energy to eject the electron. If I have to take it out from the surface of metal, I have to provide energy. Same here, energy is required when stable frequency light is strike on the surface of matter. So this is known as photoelectric effect, is action of electron from the surface of metal when light of suitable frequency strike on it. Dear student, this experiment was performed by the Hertz at different conditions, and some observation were noted down. What were these? One by one we will discuss. First is there, electrons are ejected as soon as radiation strike the surface. There is no time lag. Means if now the radiation strike, same time electron ejected out. There is no difference. There is no difference of the seconds, right? As soon as it strike, same time electron ejected out. Okay. Second is threshold frequency come in existence. What is threshold frequency? It says that certain minimum frequency of light is needed to eject out the electron. That minimum frequency of radiation is known as threshold frequency. And threshold frequency varies metal to metal. The cesium metal, which is used in photoelectric cell, right? Photoelectric cell, cesium, rubidium, sodium, they are the best metals, right? So generally cesium is used there. So it varies metal to metal. The minimum frequency required to eject electron, known as threshold frequency, it is varies metal to metal. Next is number of electron ejected decided by the intensity. Means how many number of electrons will get ejected out? 1, 2, 3, 4, 5, 10, infinity, whatever. That depends upon the intensity of light. If light is very bright, more number of electron. If light is dull, right? It is giving less number of electrons. So number of electrons ejected out is decided by intensity, right? Not by the frequency. So what frequency decides? Then we did next condition there, and we find out it is kinetic energy, not number of electron, which is decided by the frequency of incident radiation. The radiation which is strike on, that is known as incident radiation. So incident radiation frequency decides kinetic energy. So kinetic energy directly proportional to frequency of light. Okay, these were the observation, right? And if we plot graph between your kinetic energy, frequency and intensity, then what is the outcome here? See, if towards x-axis we are keeping frequency and kinetic energy to y-axis. So what is here as the postulate is there? This postulate number 4 here given graphically. It says, it's clear here, minimum frequency, threshold frequency, nu naught, and as frequency increases, kinetic energy also increases. So it is directly proportional. So it is directly proportional. Yes. And if we increase intensity of light, is any change in kinetic energy? No. It remains constant. It remains constant parallel to x-axis. There is no change in the value of kinetic energy if intensity of light is increased. Right? When it changes? When there is change in frequency. More frequency, higher frequency, high kinetic energy. Okay? And how it can be calculated? Dear students, the difference between the energy processed via the radiation minus energy of the required to eject electron, that is also known as work function, right? Kinetic energy equal to h nu minus h nu naught. H nu is the energy possessed via the radiation minus h nu naught is the work function, that is the energy used to the ejection of electron. So this is here about the concept. It's very crystal clear to you guys. So this is there, and at last the very interesting fact we have shot out from here, from this effect, photoelectric effect, that is about the phase. Phase is like electricity. You can not see it, but you can see the light. Dear students, we should have faith on ourselves, on our hard work, right? Because on our guides, because faith is not visible. What is its outcome? Light. We get enlightened with that. We become good conductor so that we can do miracle in life. So have faith on yourself and move ahead. Thank you.